Hello everyone. Today we'll be solving EDEXCEL IGCSE 921 Chemistry Paper 1C May 2021 question paper. In this particular question paper, today we'll be solving from question number 8 to question number 10. This is a part 3 video. Guys, if you haven't watched the part 1 and part 2 video, the link will be provided in the description, or I will put them in a playlist together. Question number 8. A scientist finds an unlabeled bottle on a shelf. She thinks the bottle contains a solution of ammonium sulfate. Describe tests the scientist could do to show that the solution is ammonium sulfate. So basically, in order to test for the ammonia, the scientist can add sodium hydroxide and then warm that particular solution. And then whatever gas is evolved, the scientist can test with a damp red litmus paper. The litmus paper will turn blue if ammonium ions are present. And to test for sulfate ions, the scientist can add dilute nitric acid. Followed by that, the scientist can add some barium chloride solution or barium nitrate solution. If there is sulfate present, white precipitate will form. Guys, for bonus, uh, let me show you how we test for ammonium ions. So basically, when we test for ammonium ions all right, to presence for ammonium ions with sodium hydroxide with NaOH. So basically, what happens is that the ammonia ion, it gets displaced with sodium hydroxide. So we are going to see sodium ion along with water and formation of ammonia. So this is basically the ionic equation that is standing in our way. All right. And then once the ammonia is formed, it forms gas. We know that ammonia can be tested with red litmus paper. So basically what happens is that once the red litmus paper touches the ammonia gas, it turns, damp red litmus paper turns blue. And the way we do the sulfate test is because if we have barium ions forms a white precipitate with sulfate ions, and that forms a barium sulfate white precipitate, which is why we can detect it very easily. Guys, moving to the next question. Ammonium sulfate is often used as a fertilizer. It is prepared by reacting ammonia with sulfuric acid. Name the type of reaction that occurs between ammonia and sulfuric acid. Guys, since ammonia is a base and sulfuric acid is an acid, obviously, so acid-base reaction is called a neutralization reaction. So this reaction will be termed as neutralization. Next, part 2. Write a chemical equation for the reaction of ammonia with sulfuric acid. So a chemical equation for the reaction of ammonia with sulfuric acid. When ammonia reacts with sulfuric acid, H2SO4, it produces ammonium sulfate. So NH4 2SO4 will be produced. Next question says, draw a dot and cross diagram to show the bonding in a molecule of ammonia. Show the outer electrons only. So in that way, nitrogen, we must show it bonded with 3 hydrogens. So we will draw the 3 hydrogens. So the nitrogen can be represented with a dot. There are a total of 5 electrons in the nitrogen. And the hydrogen can be represented with a cross. There's a total of 1 electron in each hydrogen, sharing 1 electron with nitrogen, forming ammonia. Question number 9. A student uses this apparatus to investigate the rate of reaction between marble chips and dilute hydrochloric acid. We can see cotton wool, we can see marble chips, dilute hydrochloric acid, a balance. The equation for the reaction is calcium carbonate produces reaction with hydrochloric acid, produces calcium chloride, water, and carbon dioxide. State the reaction that the mass of the contents of the flask. During the reaction, the mass of the contents of the flask decreases. State why the mass of the content of the flask decreases. The reaction produces carbon dioxide gas, as we can see from the equation. And since this reaction produces carbon dioxide gas, the carbon dioxide gas escapes, and that's why the mass decreases. State the purpose of the cotton wool. So basically, whenever we are going to make react carbonate with hydrochloric acid, it does a lot of fizzing and it can basically spray. All right. To prevent that from happening, all right, so that's why we add the cotton. Explain why sulfuric acid is not a suitable acid to use in this investigation. When calcium is reacted with sulfuric acid, it produces insoluble calcium sulfate, and which will form a coating around the marble chips, and thus it will prevent further calcium carbonate from coming in contact with the acid and thereby stop the reaction. So sulfuric acid, mainly we do not use it because it is calcium sulfate is insoluble. Part B, the graph shows the student's result. Decrease in mass in gram. So time in minutes, as the time increases on the x-axis, all right, decrease in mass increases, but slowly it plateaus. It doesn't increase any longer, all right, with increase in time. In the investigation, the marble chips are in excess. Explain the shape of the graph. So at the beginning of the experiment, the curve is the steepest at the start. We can see at the beginning of the experiment, we can see it is very steep. All right, means within 4 minutes, we can see there's a considerable amount of decrease in mass. However, in the next 4 minutes, there is only a small amount of decrease in mass. So the curve is the steepest at the start because the acid concentration is the highest. The curve becomes less steep as the acid concentration becomes more and more dilute. And then the curve finally levels off when all the acid has been used up. Part 2. The student repeats the experiment using the same volume of hydrochloric acid but of half the concentration of original acid. All other conditions were kept the same. On the grid, draw the curve the student would obtain. So we can see the student repeats the experiment using same volume of hydrochloric acid, but this time the student uses half the concentration of original acid. Now, guys, you have to notice that we have used the calcium carbonate in excess. If we are using half the concentration of that particular acid, we are also going to get half the result. So here the maximum mass of a maximum mass of decrease in mass in grams was for calcium carbonate 5.2, 5.4. We can see 5.5, around 5.5. So around 5.5, 0.54 and 0.27. So we can, yeah, probably we're gonna get something like this. Part C. Explain using particle collision theory how increasing the temperature affects the rate of reaction. So we know if we increase the temperature, all right, as the temperature is increased, the rate of reaction increases because the particles gain more kinetic energy. So there are more collisions per unit time. Since there are more collisions unit time, all right, they have energy greater than the activation energy, and more collisions are successful. So this will be the points. Question number 10. The diagram shows the apparatus a teacher uses to determine the formula of an oxide of lead. Hydrogen is passed, an oxide of lead is placed here, it's being heated, and hydrogen gas is burning out of the hole. The gas that is coming out of the hole, it's a reduction tube. This is the teacher's method. Step 1. Find the mass of the reduction tube. Step 2. Add some of the lead oxide to the reduction tube. Find the mass of the reduction tube and lead oxide. Step 4. Pass hydrogen over the lead oxide and ignite the hydrogen at the hole. Heat the lead oxide strongly for 10 minutes. Keep passing hydrogen through the reduction tube until the tube and contents are cool. Find the new mass of the reduction tube and its content. Give a reason why hydrogen is passed through the reduction tube until the tube and contents are cool. So basically, if we heat up this particular oxide of lead, hydrogen will remove the oxygen from this particular lead and it will leave the lead metal behind. However, the problem is that once we basically stop passing the hydrogen, but the lead will still be hot, and it will then be able to react with the oxygen in the air. So our answer will be very simple, so that the hot lead does not react with oxygen in the air to convert back into lead oxide. Describe what the teacher should do next to make sure all the lead oxide has been reduced to lead. So the teacher can basically repeat the heating process until the mass of the lead remains constant. It doesn't change. So which will indicate that there is no more oxygen present. Part B. The teacher completes the experiment and obtains these results. Mass of reduction tube 23.50. Mass of tube plus lead oxide 28.64. Mass of tube plus lead 28.16. Calculate the mass of lead formed. To obtain the mass of lead, we need the mass of tube plus lead and mass of the reduction tube. So 28.16 minus 23.50. So this gives us 4.66. So mass of lead 4.66. Calculate the mass of oxygen removed from the lead oxide. In order to find out the mass of lead oxide, oxygen in the lead oxide, we need the mass of lead oxide plus mass of tube and mass of tube plus lead. So 28.64 minus 28.16. So 0.48 grams of oxygen. Determine the empirical formula of the lead oxide. Okay, very good. So in order to do the empirical formula, first of all, we must write lead and oxygen. The mass of lead is 4.66. The mass of oxygen is 0.48. Then what we need to do is divide the mass by air. So lead has a mass of 207 and oxygen has a mass of 16. So this gives us 0.0225 and gives us 0.03. So what we can do is we can divide 0.0225 with 0.0225, which gives us 1, and 0.3 we can divide it by 0.0225, which gives us 1.33. We can multiply both sides by 3 to get to the whole number. So this gives us 3 and gives us 4. So our empirical formula will be Pb3O4. Guys, one word of reminder. You have got this particular value 1.33. Usually, beforehand, before your O levels, you had the tendency of making this particular number whole number. Please do not repeat that particular process here. If you receive anything in fraction, try and multiply some reasonable number to get them into whole number if you can. Part C. The insoluble salt lead 2 chloride PbCl2 can be prepared by reacting solutions of lead nitrate with dilute hydrochloric acid. Complete the equation for the reaction by adding the state symbol. So we have lead nitrate, which is aqueous. We have hydrochloric acid. We know hydrochloric acid is also aqueous. And that produces lead chloride, which is solid, and nitric acid, which is definitely aqueous. So show that the maximum mass of lead chloride that can be made from 0.03 mole of hydrochloric acid is about 5 gram. Okay, so we know the number of moles of hydrochloric acid. Now we need the number of moles of lead chloride. As we can see, number of moles of hydrochloric acid, all right, is equals to half the number of moles of lead chloride. 0.037 divided by 2, it gives us a value of 0.0185. Now we need to know the MR of PbCl2. All right. Oh, so we already know the MR of PbCl2, so we need the mass of PbCl2. So the mass of PbCl2 is equals to 0.0185 multiplied by 278 gram per mole, which gives us 5.143. So technically, this is the theoretical maximum mass that we can gain in terms of mass of lead chloride. In reality, the reaction is not going to be the same. In reality, we would get much lower than that because many of the reagent would be lost when transferring from one container to another. And also reagent will be lost during the filtration process of the lead to chloride. Guys, thank you for joining the video today. If you like videos like this, please subscribe to the channel and stay with us connected. Thank you. Bye-bye.